Going to talk about higher order differential equations. There are two solutions of a higher order differential equation. One is called the YP, called particular integral. That is when f of d of y is equals to f of x. And the another one is YC, also called the complementary function when f of d of y is equals to 0. The total solution is y is equals to yc plus yp, that is the complementary function in addition to the particular integral. We're only going to learn about the complementary function, how that is solved, and what are the cases to solve different type of complementary functions. Now, the first case to solve a higher order differential equation, the complementary function of a higher order differential equation is when the roots are real and non-repeated. That is, for example, we have a equation here, d square plus 5d plus 4 times y is equals to 0, where d is equals to d by dx, the derivative of some function. For example, y in this case. The equation d square, we will take the equation d square plus 5d plus 4 is equals to 0. Then by factorizing it, we will get our roots, two roots. In this case, as you can see, d is equals to 1 and d is equals to minus 4. Sorry, minus 1 and minus 4. yc will be equal to c1, the first root, which is the lower value, c1 e raised to the power minus x, minus 1x or minus x, plus c2 e raised to the power minus 4x. This is the solution of the complementary function in the case of real and non-repeated roots of some equation. Another case is when the roots are real and repeated. For example, the equation here we have d square minus 60 plus 9 times y is equals to 0. D square, by factorizing calculations, we get d is equals to minus 3, d is equals to 3 and d is equals to 3. So as you can see, the both values are identical, they both are positive. We can write the complementary function as yc is equals to c1 plus c2 x times e raised to the power 3x, as e is the coefficient, is the root we found out. Now if we would have gotten 3 roots, for example, the equation would have been d cube or something, and we would have gotten 3 roots. We would have written 3 identical roots. We would have written c1 plus c2x plus c3x squared times e raised to the power the root times x. The third reason, the third case to solve an complementary function of a higher order differential equation is when the roots come out to be imaginary and they're not repeated. For example, we have equation here d square plus 2d plus 2 times y is equals to 0. Now factorizing it and getting our roots come out to be d is equals to minus 1 minus iota and d is equals to minus 1 plus iota. Now when we'll write our complementary function, we'll write it as e raised to the power minus x because the real part here is minus 1. So we'll write it at e raised to the power minus x times c1 cos x. The cos, as we know, cos minus theta is equals to cos theta, positive cos theta. So the minus iota, when it will only it's minus 1 iota actually, the number attached to it will become the angle here, and as we know, cos minus theta is equals to cos theta, so this will become c1 cos x, and here it is plus 1 iota, so this will become c2 sin x. This will be the complementary function of an imaginary function and of an imaginary root. Thank you. Of solving an complementary function, solving a complementary function of a differential equation of a higher order is when the roots are imaginary and they are repeated. For example, our equation here is d raised to the power 4 minus 4d cubed plus 8d square minus 8d plus 4 is equals to 0. Now solving by complex roots method or by the scientific calculator, our roots come out to be d is equals to 1 plus iota, d is equals to 1 plus iota, d is equals to 1 minus iota, and d is equals to 1 minus iota. The method to write this complementary function is y(c) is equals to e raised to the power x times c1 plus c2x times cos x plus c3 plus c4x into sin x. Thank you.